All right, my name's William. Let's do some math. I'm going to walk through another example of doing partial fraction decomposition, this time with something a little bit more complicated. The goal is still to take this rational expression and break it up into two fractions. The first step, just like last time, is going to be to ask whether or not it's a proper rational function. And once again, we happen to have been given a fraction that is proper. The top is a second power polynomial, and the denominator is a third power. So we don't have to do any long division. That's done. Step 2 is to factor the denominator. That will let us come up with the fractions on the other side of the equal sign. In this case, the denominator will factor pretty nicely if we do some factoring by grouping. So I'm going to look at the first two terms, and I'm going to pull out an x squared. That's going to leave me with x minus 1. And then from the second two terms, the 2x minus 2, I'm going to pull out a 2, leaving me with x minus 1 again. That lets you pull out the x minus 1, and then by factoring by grouping, you have x squared plus 2 and x minus 1. So the fraction that we're working with is actually 5x squared minus 2x plus 3 on top, and then on bottom, we have these two factors, the x squared plus 2 and the x minus 1. The x squared plus 2 is not a linear factor. It's a non-reducible quadratic factor. So step 3, when we are setting this equal to the appropriate terms, is going to require us to do something a little bit more complicated. The linear term, the x minus 1, can just be put underneath a simple a, but the quadratic term, the x squared plus 2, has to be given a bx plus c factor up there on top, and then we will have to solve for the b and the c. And that's what makes this a little bit more complicated, but still not too bad. Step 4, once again, we're going to clear the fractions by multiplying both sides by the denominator over here, the x squared plus 2 and the x minus 1. When you multiply the left side of the equation by those two factors, you're left with just the numerator, the 5x squared minus 2x plus 3. On the right side, the x minus 1 cancels, but you have the x squared plus 2 still multiplied by the a, and the bx plus c is going to wind up being multiplied by the x minus 1. Make sure that you remember to keep the parentheses here around the bx plus c. If you don't have it, it might look like you were just multiplying c by the x minus 1, and that will give you the wrong answer. Make sure to group correctly. So the next step in the previous example was to pick some clever values for x. But if you look at this term here, the x squared plus 2, there's not going to be a clever value for x that you can pick in order to get rid of that term. Still, we can get rid of the x minus 1 over here if I choose x to be 1, and so that will give us a good head start. That'll help us to solve for a. So I'm going to pick x equals 1, plug that in, and see what I can get. On the left side, I have 5 times 1 squared minus 2 times 1 plus 3. On the right, I have a times 1 squared plus 2 plus b times 1 plus c times 1 minus 1. This over here is 0, so all of that term is gone. The rest of this is just 5 minus 2 plus 3 equals a times 1 plus 2, which is 3. 5 minus 2 is a 3, add 3. You have 6 over here is equal to 3 times a. Divide both sides by 3, and we get an answer of 2 for A. I can go back and plug that into A up here, into this equation, and that'll give me a head start on solving the other things, but we're still not going to be able to solve for B and C at the same time by picking one other clever value. But let's see what we've got. We have 5x squared minus 2x plus 3 equals 2 times x squared plus 2 plus bx plus c times x minus 1. I can get rid of b if I plug in a 0 for x, so that seems like a reasonable choice for the next step. Let's try x equals 0, see what we get. This should work out pretty well. The first things over here disappear because those all have x in them equal to 0. Here we have 2 times 0 squared plus 2 plus b times 0 is 0, so there's just a c in this parentheses, and then it's 0 minus 1. So that means 3 equals a 2 times 2 here, which is a 4, plus c times a negative 1, it's a negative c. I'm going to subtract 4 on both sides, so I get negative 1 equals negative c. In other words, c is a positive 1. So that's not bad. Because I was able to come up with the a first, I was then able to pick another value for x that let me come up with c. And that makes it easier. You could have gone through and done some type of synthetic division or something, or comparing coefficients on this one. And all of these different processes will work. They get you the right answer. But if you can pick that clever value for x as a starting point, it can simplify a lot of your work. So now that I have a and c, I should be able to go back through and pick another value for x and come up with my b. Doesn't really matter what, but I am going to pick, what did I choose, 0 and 1? I guess I'll choose 2. And we'll go from there. That gives me 5 times 2 squared minus 2 times 2 plus 3 equals 2 times 2 squared, I will write it out, plus b, which I don't know yet, but x is 2, c I just found was 1, and I'm plugging in 2 for x over here again. So all of these are just numbers that will do a little bit of algebra crunching. The only variable we really care about is right here, that unknown b. So this will be 5 times 4 minus 4 plus 3 equals 2 times 4 plus 2 plus, this is 2b plus 1, and this over here is just a 1. That'll be something I can ignore. 20 minus 1, 19 over here, 2 times 6, which is 12, plus 2b plus 1. So if I combine those two things, that's 13. Then subtract the 13 over, and I'm left with a 6 equals 2b. Then divide by 2, and finally I have 3 equals b. Feel free to slow down and take more lines to write out the algebra there. You may have been able to follow what I was doing without problems. Maybe you wished I had slowed down. It is up to you how much you write, but if you don't write enough, you may not get the right answer. So make sure that you are careful, especially until you have done this process enough to be able to get all of the letters that you need. Oh, and you know what I almost forgot? Step 6. I was just going to give up, but we have to write the complete answer. Because remember, our original expression, this thing here, needs to be equal to some stuff that I have to replace with A's, B's, C's for numbers. So A was 2, and that was over x minus 1. So 2 over x minus 1. And B plus C, bx plus C was over x squared plus 2. B was 3, C is 1. So this is 3x plus 1 over x squared plus 2. So this is my partial fraction decomposition. And I would have forgotten to do that. Don't make the same mistakes as William. Remember to finish writing your answer.